So just a reminder, here's how to do the volume and the surface area of a frustrum. So first of all, let's do volume. So our strategy is simple. We're going to basically work out what the volume of the original cone would have been, and then we're going to subtract the part of the cone that's been cut off to leave us with a frustrum. Right, so we use similar triangles for this. We are going to draw the big triangle, which would be for our big cone, and then we're going to draw the small triangle, which is for our small cone. And obviously they're both right angle triangles. Okay, so we know that the one that's been cut off is our height. That's the thing we don't know, but we know that the base would be 4 because that would sit on top of the frustrum. Okay, we know the base of the big triangle is 10 because that is the base of the frustrum. Okay, so that means basically if the big triangle would have been the original cone, that means it's h plus the 3 that's left behind after the top is cut off. Right, so now we need a scale factor. Well, 4 times what is 10? Well, that's 4 times 2.5. 2 times 4 is 8, and another half on, that's 2, get 10. So our scale factor is 2.5. So now we set up our equation. We know that 2.5 times h, so if I enlarge the small triangle by 2.5 times, I get h plus 3. So now I have to do is find h. I'm going to take away h from both sides. I've got 1.5h equals 3. And now I'm going to divide by both sides by 1.5. And that means that 1h equals 3 divided by 1.5. That means that h is 2. So now I know that the part that's been cut off is 2 tall, and the original cone would have been 5 tall. So now I can start to do the actual maths. Right, so big cone, big cone would have been 1/3 pi r squared times height. So the big cone has a base of 10, so 10 squared times 5. Okay, and that gives me 500 pi over 3. I'm going to subtract the smaller cone. Okay, and that would be 1/3 pi times r, the base, 4 squared times the height, which we found was 2. And that gives me 32 pi over 3. And then when I subtract those two, I get 156 pi, which is roughly 490 centimeters cubed. And that is my volume. Okay, now if we're going to do surface area. So surface area, same thing. It's exactly the same idea. I'm going to take my big cone. I'm going to subtract the part of the cone that's been cut off. But then I have to add a lid for the top of the frustrum. So now I've got a formula for the surface area of a cone. That's pi r squared times pi r l. I'm going to subtract the curved part for the small cone, which is pi r l. And I'm going to add the lid, which is just pi r squared. Right, okay. So I need to know what L, the slanted length, is for the big one. So I know that it is 10 wide and it's 5 tall. So we use Pythagoras. I've got 5 squared plus 10 squared, that's 125. So L equals the square root of 125. I need L for the small triangle as well. For the small triangle, same thing. I know that that's 4 wide and it's 2 tall. So I've got 2 squared plus 4 squared. That gives me 20, and therefore L is the square root of 20. So now, the only thing I've got left to do is to work out. So I'm going to subtract that from that. I'm going to add my pi r squared, and the small lid is going to be pi times 4 squared. Okay, and my pi RL is going to be pi times 4 times the square root of 20. And then the large cone, the surface area of the cone is going to be pi times 10 squared plus pi times 10 times 5. So that's what I'm going to do. I'm going to take surface area minus the curved area plus the lid, or the base of the small cone. Right, okay, now there's a good bit of revision for surds here as well. So I've got pi times 10 squared plus pi 10 square root of 125. I'm going to subtract pi times 4 times square root of 20. I'm going to add pi times 4 squared. Right, well, I can add these two together because I'm just adding up lots of pi. So 10 squared is 100, 4 squared is 16. I've got 116 pi. Now I'm going to add my surds. But remember, we can simplify surds. So 10 root 125 is the same thing as 10 square root 25 times 5, which means that I can write that as 10 square root of 25 is actually 5 times the square root of 5. So that's 50 square root of 5. Same thing in the other one. I've got 4 square root of 20. I can write that as 4 times square root of 4 times square root of 5. We know the square root of 4 is 2. So that's 4 times 2 square root of 5, 8 square root of 5. Okay, so now I've got ten pi square root of 125, which we said is the same thing as pi times 50 root 5. And I'm subtracting pi times 4 times the square root of 20, which we just found was the same as pi times 8 root 5. So I can collect together my like terms, which are the square roots of 5, and make this as simple as possible, which is 116 pi plus 42 root 5 times pi. And that is roughly 659 centimeters squared. Remember, squared because area, cubed if it's volume. And that's it.